Hello again, Math 95. We are on to section 8.5, which is solving equations by factoring. So it's taking what we've learned about factoring and using that to solve equations. So let me just show you one example. It's not going to be much more than what you've already done. Let's say we have already factored this. See, notice this is now an equation. It's not just an expression because we have an equals 0. So now we're not just trying to factor an expression, we're trying to solve. We're trying to solve for x. We're trying to say what value of x makes this a true statement. What is the missing link here? What's the missing value of x that actually makes this work? Okay, so this left side has already been factored for you. And so it's just a matter of solving for x. Let me take an aside here and show you how this is going to work. Let's say we have a times b equals 0. If we have a times b equals 0, that would be true if a equals 0. Then it wouldn't even matter what b is. If a is equal to 0, this is a true statement. Or if b were equal to 0, then it wouldn't matter what a is. It would be a true statement, right? If a is 0, no matter what b is, 0 times anything is 0. Or if b was 0, it wouldn't matter what a is. Anything times 0 is 0. Or if both of them are equal to 0, it's still true as well. If either one or both are equal to 0, we have a true statement. That doesn't work for any other number. Like if we had a times b equals 5, we can't say a equals 5. And b equals 5, because that wouldn't be true. If a is 5 and b is 5, that's going to equal 25, not 5. So it only works when it's equal to 0. So factoring only works when you have 0 on one side of the equation. That is the key. So if we don't have 0 on this side of the equation, we have to make it be 0. And I'll show you more about that later. But when it is equal to 0, if this times this equals 0, then one of these two things must equal 0, or both. This is like the a and this is like the b. So what we do is we set both of those things. I say x minus 5 equals 0, and I say x plus 2 equals 0. And I solve both of them. I solve this by get x by itself by adding 5 to both sides. And I get x equals 5. I solve this one by subtracting 2 from both sides, and I get x equals negative 2. And here are my two answers. I have two answers for x. And I usually will have two answers for x on these kinds of problems. Most of the time these problems are quadratic equations. Let me just give you some rationale, a feel for why you have more than one answer. Okay, so a lot of times you've been dealing with linear equations, and when we're doing linear equations, we usually, when we set it equal to 0, we only get one answer. But now we're dealing with nonlinear equations. It means the variable is not just an x, but if we were to multiply this out, this would be an x squared. And that's not a straight line, that's a curve. And so when we have a curve, a lot of times it's going to be two answers for x. In the real world, you can think about it like this. If I throw in a ball, and that ball follows a curved path like a parabolic path, a parabola, and I say, when does the ball reach this height? When does the ball reach this height? Well, it happens on the way up and on the way down. So we have two answers for when it reaches that height. That's kind of what's going on here in the math of solving these equations. So we get two answers for x. If we were to plug the 5 in, we would get this to be a statement. If we plug the negative 2 in, we would get this to be a true statement. All right. So let's go on to another one. Let's say we have w squared minus 2w equals 8. Uh-oh. What did I say had to be true about this? What does this have to be? Be what? 0. Well, we can make it be 0 by moving the 8 over to this side. I can do that by subtracting 8 from both sides. when I do that, the 8 is not a like term with any of these. It's not going to combine with them. It's just going to be written beside them. So I get w squared minus 2w minus 8 equals what? Now, what do we have on this side? We have 0. So now factoring is a valid way to solve this. All right, so go ahead and try to factor this. If you want to pause it and do it, that's good. If we factor this, what do we get? We get w and w. And what multiplies to get negative 8 and adds to get negative 2? Wouldn't that be a negative 4 and a positive 2? So now we set both of these equal to 0. I add 4. I get w equals 4. I subtract 2. I get w equals negative 2. Those are my two answers. All right. Let's do a few more. Okay. Remember what we should always look for first? A GCF. On these others, we could have got a GCF first. There was no GCF to take out. But on this one, there is. So we better do it. What's the GCF that can come out of here? 4, 26, and a 30. I believe that's going to be a 2. I can factor out a 2. I can't factor out an x because this term doesn't have an x. So just a 2. That leaves me with 2x squared plus 13x plus 15. And so then I do the AC method here. That's going to be x squared plus 13x plus 30. And what can multiply to 30 and add to 13? That'll be 10 and 3. So it's going to be x plus 10, x plus 3. Remember to put the 2 back under there. That's what students often forget on the AC math, so don't forget that. Don't forget to take that, whatever number this is that you multiplied down here earlier, and put it back under there. Reduce it or move the thing in front of the x. So that gives me x plus 5 and 2x plus 3 with this extra 2 on the outside. And now I have 3 factors. I have this, this, and this. So I say 2 equals 0. I say x plus 5 equals 0. And I say 2x plus 3 equals 0. So if I say 2 equals 0, there's no x there to even solve for. And 2 does not equal 0. So I don't get a solution from that factor. Here, I subtract 5. I get x equals negative 5. Here, I subtract 3. 2x equals negative 3. Then I have to divide by 2. And I get x equals negative 3 halves. So I get two answers here, negative 5 and negative 3 halves, or negative 1.5. Okay, another. X squared minus 10x plus 25 equals 0. Go ahead and try to factor that. X and x. How does it factor? Negative 5 and negative 5. So notice, we're doing the same kind of factoring we've been doing. And there's really just one more little step to do, and that's to set each factor equal to 0. So I'm going to set x minus 5 equal to 0, and since this is the same thing, I'd get the same thing with both of them. You don't have to do both of them, since I'm going to get the same thing. I add 5, and I get x equals 5. So in this case, I only got one answer. Graphically, that would look like this. It would be a curve that would hit the x-axis at exactly the turning point, so that it would touch the x-axis in that one place instead of crossing it and crossing it again in two places. If you were to throw a ball, it would be like, when does it reach this height? Well, only one time, right at its peak. Okay? So, here's another way this question could be worded. Find the x-intercepts of the graph of f of x equals x squared minus 7x plus 10. All right, this is the same kind of problem. It's just written a little bit different way. When it says find the x-intercepts, it means find where this thing hits or crosses the x-axis. And when it hits the x-axis, we always have a y-coordinate of 0. Everywhere, every point on this x-axis has some x coordinate, but the y coordinate is going to always be 0. Because we're not going up, we're not going down, we're at 0 on the y-axis. So to find the x-intercepts, you put in 0 for y, or in this case for f of x. Put in 0 for that. So we get 0 equals x squared minus 7x plus 10. If you feel more comfortable rewriting that as x squared minus 7x plus 10 equals 0, that's fine. If you have to rewrite it that way, that's the same. You're doing the same thing. So I'm just going to keep going with this. Factor this side here. We get x and x minus 5 minus 2. So I'm going to get x minus 5 equals 0 and x minus 2 equals 0. I'm going to add 5. I'm going to get x equals 5. I'm going to add 2. I'm going to get x equals 2. So there are my two x-intercepts. That means it's going to hit the x-axis at 2 and at 5. All right, if we were to see it on the graph, that's what it would look like. All right, let's do some more. What number am I on? 6. Okay, remember that for factoring to work at all, one side of the equation has to be what? 0. So we're going to have to move this 18x over here so that we'll have 0 on the right side. So 6x squared minus 18x equals 0. Notice these two terms did not combine. They're not like terms. You just write them beside each other. Now, how can I factor this? It's not a trinomial. Do you remember back from lesson 8.1 and 8.2? It's going to be just GCF. Factor out the GCF. What is the GCF you can factor out of these two terms? It's going to be a 6x. I can factor 6x out of both of those. What's left when I factor 6x out of the 6x squared? I'm left with simply an x. And what's left when I factor a 6x out of an 18x? I'm left with a 3. So now I set the 6x equal to 0 and the x minus 3 equal to 0. So 6x equals 0. X minus 3 equals 0. Here I need to divide by 6. 0 divided by 6 is still 0, so x equals 0 is one of my answers. Here I add 3, so x equals 3 is my other answer. Sometimes Math Excel just wants you to put a comma between the two answers, so you just put 0, comma, 3. And that'll be both answers written in one answer blank. All right, more. Okay, go ahead. What do I need to do here? What does one side of the equal sign have to be? It has to be 0. So move these two terms over by doing the opposite of what they're doing. I'm subtracting 5x. I'm adding 20 over here as well. Notice I do have like terms here. The negative 8x and the negative 5x are going to combine together. So that's 2x squared minus 13x, and then the plus 20 does not have any like terms, so you just write it beside each other. Okay, so what kind of factoring should happen here? I should look for a GCF, but there's not one. So what kind of factoring should I do? Looking like AC method to me. Slip, slide, slip. So it's going to be x squared minus 13x plus 40. What multiplies 40 adds to negative 13? That'd be a negative 8 and a negative 5. Don't forget, AC method, slip, slide, slip. You got to slide that 2 back up under there. Reduce, that's going to be x minus 4. That won't reduce. Put the 2 in front of the x, 2x minus 5. And I have it factored. Now I just set both of these equal to 0. Add 4, x equals 4. Add 5. 2x equals 5 divided by 2. X equals 5 halves. There's my two answers. Alright, let's try this one. What number? 8. This one's a little tougher, a little bit. The temptation here might be to say, well, it's already factored for me. I'm just going to say, well, x plus 2 equals 7 and x minus 4 equals 7. You better not do that, because this side has to be what? 0. So what do I do then? Well, I'm going to have to go ahead and FOIL that out. I'm going to double distribute that together and then move the 7 over and combine it and then see if I can factor from there. So if I FOIL this out, that'll be x squared minus 4x plus 2x minus 8. Combine my like terms, x squared minus 2x minus 8. Then move the 7. The minus 7 is going to now combine with that minus 8. You get x squared minus 2x minus 15. And then you factor that. What multiplies the 15? Negative 15 and adds the negative 2. That'd be a negative 5 and a positive 3. So I set both of these equal to 0. I'm just going to kind of do a little shortcut here. What's x going to equal? It's going to equal positive 5, and it's going to equal negative 3 whenever I set them equal to 0 and move those things to the other side of the equal sign. All right. Let's see here. Okay, you know what to do here, don't you? Move the 42x. Move the 8x squared. And I'm going to write this in order. The standard order would be to put the highest exponent first and go descending order from there. So the 2x cubed should come first. The minus 8x squared come next. Then minus 42x. And it equals 0. What do we look for now? What do we look for first in factoring? GCF. Is there a GCF? There is. 2x. What's left? I'm left x squared minus 4x minus 21. This can factor some more. Bring the 2x along for the ride. This is just going to be x and x. And that's going to be minus 7 and plus 3. So set this and this and this all equal to 0. 2x equals 0, x minus 7 equals 0, x plus 3 equals 0. Here I need to divide by 2, but 0 divided by 2 is just 0. Here I add 7, I get 7. So I'm just going to put a comma 7, and if I subtract this, I get negative 3, so negative 3. So here are all three of my answers. 0, 7, and negative 3. Alright, let's see. What else can we do here? Here is another kind of an equation. Alright, here is another kind of different looking problem. Just stare at it for a minute. See if, just take it in. So we're letting f of x equal this expression. We have this function. Part A to this problem says find f of 5. This does not mean f times 5. Hopefully you remember that. When you have this number inside this parentheses beside f, it means f of 5, which means you plug 5 into f, you plug it into x. Plug it in for the x to find the value of that function when x is equal to 5. So to do that, I just plug 5 in for the x. So it's 5 squared minus 3. I'm plugging in 5 for that x as well, minus 23. So that's 25 minus 15 minus 23. So 25 minus 15, that's 10 minus 23. 10 minus 23 is negative 13. So it looks like the answer is negative 13. On part B, it says find x when f of x equals 5. So I'm not plugging something in for x now. I'm finding x. I'm plugging something in for f of x. So I'm not putting the 5 for the x, I'm putting the 5 in the place of the f of x. So 5 goes here. And I've got to solve for x on this problem. Do you see the difference? F of 5 means I plug the 5 in for the x, and I just do some arithmetic to find the value of f there. Here, I've got to find x, so when f of x equals 5, so I got to plug 5 in for the f of x. and then I have to do some solving in order to find x here. So if you feel more comfortable by writing x squared minus 3x minus 23, and if you want to put the equals 5 on this side, that's totally fine. But I'm going to keep going here. I'm going to solve this. Remember, one side of the equal sign has to be 0, so I'm going to move my 5 over here. So 0 equals x squared minus 3x minus 28. I'm going to factor that. What multiplies to get negative 28 and adds to get negative 3? I believe that's going to be a negative 7 and a positive 4. So now if I solve both of these, I'm going to get x equals positive 7 and negative 4 whenever I set them equal to 0 and move them over. So the values of x when f of x equals 5 are both 7 and negative 4. It means that that function hits the height of 5 when at both of these values for x. All right. Now, I need to show you an example in your book here. All right, let me see if I can zoom in on that. All right, it says the graphs of those three functions are graphed right here for us. So this one, y equals x squared minus 10x plus 28, that's this blue curve. Notice it says it right here. Y equals 7 is this red line. Y equals 3 is this, what color is that? I think it's a black line maybe. And then y equals 1 is this green line. So it's actually 4 different functions, the curve and the 3 lines. And it wants me to just use this graph to solve these 3 problems. So you could solve these, using a paper, but it doesn't want you to, and it's easier if you can just know how to do it by looking at the graph. The question is, when does x squared minus 10x plus 28 equal 7? Well, the left side of this, x squared minus 10x plus 28, is this blue curve. And the right side is this red line. So when the left side equals the right side, I just find where these two things cross. And they cross at this point and at this point. And since I'm just solving for x, I just give the x values at those 2 points. So the answers would be 3 and 7. So the answer to number 1 is x equals 3, that 3, and x equals 7 because of that 7. All right, if those points weren't explicitly given, you would just have to look at your x-axis and see where do they cross. Well, they cross at 3 x-axis, and it crosses at 7 on the x-axis. All right, see if you can number 2 now. Okay. The left side again is the blue curve. The right side now it says 3. Well, that's this black line right here. When does this blue curve cross this black line? It only happens in one place. This point right here. What is that point? It is x equals 5. When the x value is 5 is when that point occurs. So the answer to that one is just 5. Number 3, when does this blue curve hit 1? Well, if 1 is this green line, the question is, when does the blue curve hit the green line? Then the answer is never. So the answer there would be no solution, or you might say no real solution, no real number solution. All right, we're going to talk about imaginary solutions, complex number solutions. We're going to talk about that later on in Chapter 9, not on Chapter 8. And I think we are finished with Chapter 8. That is the end of Section 8.5. We get to 8.4. We're not going to do 8.4. So we're done with Chapter 8, and we're ready for a test. So go ahead and good luck on 8.5 homework. I will get a practice test ready for you, and also a test, and I'll be in touch about all that.